Imagine a bullet train engine running at top speed and smashing straight into a ship. Now imagine being hit by something with 15 times more kinetic energy. That's right, we are talking about BrahMos. So, make yourself comfortable, fellas, because today we'll explore how this supersonic missile can make enemy ships very uncomfortable. BrahMos is developed by BrahMos Aerospace, a joint venture between DRDO of India and NPM of Russia. This 3,000-kilogram missile has a length of 8.4 meters, a wingspan of 1.7 meters, and a diameter of 670 millimeters. The outer shell is made from several grades of wrought aluminum alloy. Flying above Mach 2 heats up the outer shell to 654 degrees Celsius. This might cook a garlic naan in less than 1 minute. The nose of the missile is typically pointed and streamlined to minimize drag and improve stability during flight. The inlet compresses incoming air as the missile travels at high speeds. Its shape is designed to slow down air and increase its pressure. This part is called the diffuser. It is made from nickel-based alloys or composites to endure the heat generated by air compression. Ramjets often have a grid that acts as a flow distribution control device to uniformly distribute shock boundary interaction across the tube. The radar section in its cone is typically made of duroid or avcoat, with layers of PMR-type polymer resin and glass honeycomb to withstand aerodynamic heating. It has mechanical radar guidance and also uses GPS GLONASS Gagoon satellites. It is also equipped with passive infrared guidance and electro-optical system. To circumvent electromagnetic jamming, the missile employs frequency hopping. It includes a variant of DSMAC, or Digital Scene Matching Area Correlator, to identify locations and targets by matching live images with pre-installed ones. In addition to that, it also has TERCOM, or Terrain Contour Matching Guidance technology, as part of its navigation and guidance suite. This system enables BrahMos to navigate accurately over various terrains with ease. Behind the control section is its warhead. The version carried by fighter jets has a 300-kilogram warhead. The fuel injector mixes kerosene TS1 or T6 with the compressed air. It must ignite within milliseconds, even at subsonic speed, otherwise, it will get blown out with fast-moving air. To maintain flame constantly in a high-velocity airstream, some sort of shielding at the flame source is necessary. Such a device is called a flame stabilizer. The nozzle is engineered to allow high-pressure, high-temperature gases to expand, generating thrust. It is typically made from alloys or ceramics to handle the extreme temperatures. These protrusions on its body are called bypass fairings. They are made to streamline the aerodynamic profile of BrahMos. The wings and fins on BrahMos are used to stabilize and perform maneuvers during flight or to change its trajectory. Till June 2016, the range of BrahMos missiles was capped at 290 kilometers. After India became a member of the Missile Technology Control Regime, export limitations on weight and range were lifted. Now it can go beyond 600 kilometers with just a software update. BrahMos has a two-stage propulsion system. During a ground launch, it fires perpendicular thrusters from its nose cap to adjust its orientation. The cap yeets itself after that. At this stage, a solid propellant rocket engine accelerates the missile in the desired direction. Later on, the liquid-fueled Ramjet engine sustains supersonic speed with greater efficiency. Depending on the mission, BrahMos may climb to a height of 15 kilometers, where it acquires the general location of its target. At this stage, it switches off its radar homing head and becomes invisible to the enemy. Then it dives down like God of War and flies close to water at a height of 3 to 10 meters, always below the enemy ship's radar. It switches on its head again for precise targeting seconds before impact. What's a radar horizon anyway? It is the height below which radar can't track anything due to the Earth's curvature. Flat earthers won't see a problem here, but that's okay. BrahMos will be in radar shadow region until it is too late to act. Mach 2.8 equals 3,457 kilometers per hour, which means plenty of time to panic. When a salvo of BrahMos missiles is fired, they smartly work on a Wolfpack principle. Every other missile waits till the last one is out of the launch canister before proceeding with the mission. The missile at the front leads the pack while flying at a high altitude and shares all necessary data of ships to the rest of the missiles. Even if the leader is taken out, a new one takes its place quickly. The missiles use an in-flight information exchange system to share data with each other and assign high-priority targets automatically. Data to distinguish various types of naval targets is embedded in its onboard computer. Some missiles can sacrifice themselves to the air defenses of enemy ships as a distraction to make sure the next one completes the job. A well-executed missile strike can snap a frigate in two halves like a cookie, promote a destroyer to submarine, and send a medium cruiser to its early retirement. So, how many missiles exist in one battery of BrahMos? Each battery comprises 4 launchers with 3 missiles each, along with command and control vehicles, radar, and support units. And how many BrahMos does India have? Real figures are kept secret like most countries, but from publicly available data, the Indian Army has 335, while the Navy and Air Force reportedly have 200 each. As of now, Philippines already has it. Malaysia is also interested in buying BrahMos missile for their Sukhoi fighter jets and warships. Indonesia wants it for their fighter jets, and Vietnam also has plans to buy the naval variant. Several other countries have shown interest in buying BrahMos-II. Each BrahMos missile costs $3.5 million, roughly the same as an Aventador. But Lamborghinis can't go supersonic to protect your country. BrahMos NG is the next generation upgrade that is compact, 50% lighter, and significantly faster than its big brother, with a top speed of Mach 3.5. BrahMos-II will be the hypersonic model. It will have a range of 1,500 kilometers and travel at a speed of Mach 5 to Mach 7. Hit subscribe if you learned something new.